Welcome to Unit 8. You will see how we will use the first principle to actually trash a quadratic equation. We're going to find from the first principle the gradient function of a x raised to power 2 plus b x plus c, which is a quadratic equation where a, b, c are real constants. So Unit 8. Find from first principle the gradient function of a x raised to power 2 plus b x plus c, where a, b, c are real constants. So let's look at the solution. We are used to the principle now, gradient function. Our principle, Q arrow all over B arrow. So we go straight to our P and Q. So let's say that we all know that it is the y2 coordinate minus the y1 coordinate. So all we need to do, you have already know the principle now, we'll keep writing. So let's just go to the y2 coordinate. So from the board, we know now that we are solving an equation y equals to ax squared plus bs plus c. So that is the equation, the quadratic equation on the board. So let's get our Q arrow. Q arrow is saying that the y2 minus y1. This is actually our y1. So our y2 now is equals to a into x plus h. You know, you are becoming matured now. There are some steps I'm skipping. Plus b into x plus h plus c. So that is your y2 minus y1, which is ax raised to power 2 plus bx plus c. So you are used to it now, all over 1h. So this is the guiding principle now. We have started eliminating some minor steps. So all we need to do now is to expand. We won't do that expansion for you because by now you already know how to expand. So what you are going to get is a into x squared plus 2a into x squared plus 2xh plus h squared. So what I've just done is expanding x plus h all squared. So we won't go into the procedure of this expansion. You're already used to it. So a into x plus h squared. So of having a squared, you are now having x squared plus 2sh plus h squared. So that's what you have. So now I now approach this. So I now have plus b into x plus h plus c. So minus, this is your minus sign, will come into a x squared plus bx plus c all over h. So we'll try to do this expansion. Now you are getting stronger and you are getting used to the principles now. So we just go straight to do the expansion. So if we do the expansion, you are going to get ax squared plus 2a sh plus a h squared. So that's what you are getting. Put your bracket. Expand this, come to plus bx plus bh plus c. So you have plus c. That's what you have there. So let's put, because they are going together, so let us not put this bracket here, so that the bracket can come to this place. Plus c minus ax squared plus bx plus c all over h. So we are getting better now. So let's see how we can straighten up this equation now. So we now have equal to ax squared plus 2ash plus ah squared plus bx plus bh plus c. Let's see whether we can squeeze it in. This minus will affect everything there. You have minus ax squared plus minus, because this minus will affect it, minus bx. It will also affect this one, minus c. So let's see how we can carefully address it. So I will try to streamline it again so that the cancellation will be smaller. So from here, we know that this one is plus ax squared and this one is minus ax squared. So ax squared minus ax squared will go away. Then check, plus bs minus bs will also go away. Plus c minus c will also go away. So let's see what we can get from the outstanding factors. So we are now going to have 2axh plus ah squared plus bh all over h. So let's carefully look at it again so that we know that we are making serious progress. Ax squared is cancelled, minus as squared. B plus bx has cancelled, minus bx. plus c has cancelled minus c. So what we have is 2ash plus ah square plus bh all over h. Thank you very much. So now we can bring out our h. So h will come out. Then you are going to have 2ax. H is coming out, you have 2ax. Plus, h will come out, you have ah. Look at it very well. H is coming out, so instead of having an ah square, you now have h, you have ah. H is coming out, so what you have there is p. So, you now have h into 2ax plus ah plus b. Now, your h can cancel out. So what do you have? If your h cancels out, you are going to have 2ax plus ah plus b. Now, the principle says p tends to q. P tends to q, h tends to 0. If h tends to 0, then you have ah is equals to 0. So what you have now is equals to 2ax, where this one is 0 plus b. So your gradient function for this quadratic equation is simply 2ax plus b. So can you see how we can use the first principle of the gradient function to differentiate the quadratic equation ax squared plus bx plus c, where a, b, c are a constant? Thank you. Unit 9. Thank you very much.